Hello, let's dive into a coding problem. Today, we'll work on finding the longest palindromic substring in a given string. A palindrome reads the same forwards and backwards. If you've tackled this problem before and want a different challenge, let me know. Here's a quick example. Given the string babad, one possible longest palindromic substring is bab or abba. Constraints to keep in mind. The input string can contain letters, numbers, and special characters. You don't need to differentiate between uppercase and lowercase letters for palindrome checking. Feel free to discuss your approach and consider edge cases. And if you'd like to discuss the time and space complexity, I'm all ears. Let's get started.
Hi, thanks for sharing the question. First off, when the string can contain special character, that also include white space, right? And secondly, when we map the palindrome, do we also have to map all these special character as well?
Great questions. Yes, the string can contain special characters and white spaces. When identifying palindromes, we do include these characters, meaning we consider the entire string as is, including special characters and white spaces for palindrome checking. For example, in the string a man, a plan, a canal, Panama, the longest palindromic substring is comprised of white space, not of reconstructed letters, numbers, and uppercase. The special characters and spaces are part of the palindrome. Does that clarify things? Feel free to share your approach, and we can...
It seems that the example already ignore, right? Because a man has the white space in between, but Panama doesn't have. And also, it also have exclamation mark, but at the beginning of the string, it also doesn't have here. So do we still need to consider them?
Thank you for pointing that out. Let's stick to considering the string exactly as it is, without ignoring any characters including white spaces and special characters. So, in the modified example, a man, a plan, a canal, Panama, it would not be considered a palindrome unless we remove punctuation and spaces, which we're not doing in this exercise. So yes, consider all characters in the string for palindrome checking. Ready to discuss an approach?
Yeah, but let me simplify the example input. For example, if the input is A, B, C, B, A, bang, then this would not be palindrome because we would need bang for both front and the ending in order to make it qualify for palindrome. Is that right?
Exactly. In the example A, B, C, B, A, the exclamation mark at the end makes it non-palindromic because a palindrome would need matching characters on both ends. If it were A, B, C, B, A, then it would be a palindrome. So yes, for a substring to be considered palindromic, every character, including special characters and white spaces, must mirror around the center. Ready to discuss how you'd find the longest palindromic substring?
Yeah, the most naive approach would be do the second layer of for loop to find all the possible substring, and inside we have another for loop to check if it's a palindrome or not. And to check if a string is palindrome is pretty much moving cursor from left to right and right to left, make sure everything is mirror. Therefore, the naive solution would be ON cubed. However, we can think about maybe more optimized solution. Let me think about it a little bit.
Absolutely. The brute force approach would be ON squared due to generating all substrings and checking each for palindromicity. It's great that you're considering optimizing it. Take your time to think it through, and when you're ready, we can discuss your optimized approach.
We can do this. The first iteration, we will iterate each letter as the beginning of the palindrome. And then for each letter, we will keep expanding it. And since we need the final detection to be a palindrome, when we expand, we will expand for both left and right at the same time and keep all the string at the center. In this way, we ensure that we get into the longest expansion possible using any given letter as the starting point at the center. By doing so, the big O complexity should be O(n) squared. This comes from the first n is to iterate all the letter as a center, and the second layer of n is for expansion.
That's a solid approach, and you're correct about the time complexity being O(n) squared in this case. By expanding around each character, and between each pair of characters for even-length palindromes, you efficiently explore all potential palindromic centers. Feel free to start coding whenever you're ready. If you have any questions or need guidance along the way, just let me know.
Yeah, sounds good. Let me do coding for a brief moment. I also want to point out that another upside of this approach is it doesn't require additional linear memory. Basically, like we can process everything from the input string directly, and which is different from dynamic programming approach. Which, if you're interested, we can talk about that later too.
Absolutely. It's a clever use of the input string without needing extra storage, which keeps the space complexity low. If you'd like to explore the dynamic programming approach later, I'd be happy to discuss it. Now, take your time with the coding, and feel free to share your code when you're ready. I'll be here to help out if you need anything.
Yeah, give me about 5 minutes. Is that okay?
Take your time. I'll be here when you're ready. If you need any assistance or have questions along the way, just let me know.
Let me explain my approach. Basically, a palindrome, there are palindromes that the inner level is the odd number. For example, ABA. So we want to implement the search function to start with B and then expand like the counterpart both left and right at the same time. However, there's also palindromes that are even number, for example ABBA. In this case, we want to first check whether we start at the center root that has two characters that are the same and next to each other, and then we keep expand from there, like the other left and right. So it will be two cases here, and I will build the common function so that we can have the simplified for loop to handle both cases at the same time.
That's a coherent strategy. By handling odd length and even length palindromes as separate cases and using a common function to expand around the center, you can effectively cover all scenarios. This allows you to simplify the expansion logic and keep your code neat. Go ahead and build that common function, and then you can integrate it into your main loop to handle both odd and even length palindromes. Let me know if you need any assistance along the way.
For the case where we cannot find any output, what should we return?
If no palindromic substring is found, you could return an empty string, empty string. However, since every single character is technically a palindrome of length 1, you'll always find at least a single character palindrome. Thus, the minimum you would return is the first character of the string if no longer palindrome is found. Does that make sense for your implementation?
Makes sense. However, for the case where input string is empty string, I will just return empty. But if the input length is greater than 0, minimally I will return single character.
That sounds like a sensible approach. Returning an empty string for an empty input and at least a single character for non-empty inputs covers all cases neatly. Feel free to proceed with the coding, and let me know if you need any help or if you'd like to discuss anything further.
My apology, I forgot how substring JavaScript function work. Is it the first index and last index, or is it first index and the length to grab the substring?
No worries. In JavaScript, the substring function uses the starting index and the ending index, non-inclusive. So, substring, start index, end index will extract characters from the start index up to, but not including, end index.
Got it. Let me work out this code. I will I will finish it soon.
Take your time, and feel free to reach out if you need any help along the way. I'm here to assist you, so just let me know when you're ready or if you have any questions.
Okay, I finished the initial coding, but let me go over my code to double check and make sure I don't miss anything.
Sounds like a plan. Take your time to review your code thoroughly, and when you're ready, feel free to share it. If you have any questions or want feedback on specific parts, just let me know. I'm here to assist.
For the case where there are multiple possible of output, do we simply just return one of them?
Yes, if there are multiple palindromic substrings of the same maximum length, you can return any one of them. It's common to return the first one encountered, but any valid solution is acceptable unless the problem specifies otherwise. Just make sure to pick one consistent approach and stick with it.
I think in my case we return the first longest palindrome we found.
That approach works perfectly. Returning the first longest palindrome you find is a valid strategy, especially since the problem doesn't specify which one to return when there are multiple options. If you finished reviewing your code and you're ready to share or test it, go ahead. I'm here to assist with any further steps.
Okay, let me send to you.
Thanks for sharing your code. It looks very promising, and you're on the right track with expanding around the center. Here's a small suggestion. In the search function, the loop should check LF equals 0 instead of LF bigger than 0 to ensure it considers the first character. Also, make sure that even case is defined outside the if statement to avoid a reference error. Would you like me to call a function to display a reviewed and corrected version?
I can handle it, it's okay.
Great, it sounds like you're on top of it. Feel free to make those adjustments, and if you need any further assistance or want to discuss anything else, just let me know. I'm here to help.
I fixed the event case already. However, I want to point out that for the search function, because we assume that all the LF and RG are valid scope. The reason why I use LF greater than 0 is because I want to make sure that the input LF minus 1 would not be overflow. So I think it's already correct that it need to be greater than 0. If it's equal to 0, LF minus 1 would become negative 1, and that will cause problem.
I see your reasoning, and you're correct. By using LF greater than 0, you prevent LF minus 1 from going out of bounds, and this logic is indeed suitable for your implementation. It looks like you've got a solid grasp on the details. If you've made the necessary fixes and are ready to test or have any further questions, just let me know. I'm here to assist.